All right, section 6, we're talking geometric sequences. Back arithmetic sequences, we are talking adding, subtracting. Geometric sequences, you're talking multiplying. All right, so today you have to find what's called the common multiple, or the common ratio. So here we have a very simple sequence. I started with the number 1. Thank you, Grace. We started with the number 1. We multiplied by 3 and got 3. We multiplied by 3 and got 9. Multiply by 3 and get 27, times 3 and get 81. This is called a geometric sequence. Very simply, you're just multiplying by a common number. To find that common ratio, look at your numbers here. What is 3 divided by 1? 3. What is 9 divided by 3? 3. What is 27 divided by 9? What is 81 divided by 27? In each of those cases, your common ratio is 3. And so you just take the term and divide it by the 1 in front of it. And if all of those numbers get you a 3, you have a common ratio. Or a 2, or a 6, or a 10, or a negative number. Okay? But a common ratio is what you multiply by. Don't think divide. To find a common ratio, just take the second divided by the first. And check it, third by the second, fourth by the third, etc., etc. So I don't want you to get thrown by that. So here I have 2 examples. Common ratio. Let's just do a couple of these. What's negative 12 divided by negative 3? We should be able to do this in our head. How much, John? 4. Okay? So that's our guess. Let's check it. What's negative 48 divided by negative 12? 4. And our last one, 192. Now, you want to think it's 4, but take your calculators out and actually check that. Make sure that you get 4. If you don't have your calculators out, pull them out because we're going to crunch lots of numbers today. Okay? Someone got that confirmed? Is it 4? Okay. So, we confirmed all 3. Therefore, it's common. Luke, therefore, it's the same for all of them. All right? The variable for arithmetic sequences was little d. All right? The variable for common ratio is little r. All right? Small letter r. So r equals 4. Okay? Let's look at the next one. The second divided by the first. What's the common ratio? Negative 0.25. Negative a quarter. All right, let's try the next one. Negative 5 divided by 20. Is it the same? All right, Ryan's saying yes. Negative 0.25. Try your last one because you got to make sure. 1.25. Luke? It is? Okay. So you got to make sure that they're all the same. There's a number of really cool sequences. And in nature, we have a very unusual sequence called the Fibonacci sequence, which you study in discrete mathematics, which kind of talks about some of the golden ratios and things like that, which is really an amazing display of God's power and His design in the world. And the geometric sequences are very straightforward and hopefully very similar there. All right, let's look down at example 2. I'm telling you that we're going to try to find the next 3 terms. So we have to say, okay, how do we find them? Well, hopefully we're going to figure out that these are geometric sequences. So let's check. Someone divide, and let's see, what is 4 divided by negative 8? How much? Negative 0.5. Let's make sure that's consistent. Negative 2 divided by 4? Negative 0.5 again? All right, so it looks like our common ratio is negative 0.5. So how do I find the next 3 terms? What do I do? Abby? That's exactly right. You multiply by negative 0.5. So take your calculators. And what is 1 times negative 0.5, John? Sure. So that's negative 0.5 times negative 0.5 again. What do we get now? How much? 0.25 positive. And times negative 0.5 again? Negative 0.125. What I see, Katie, is the common error on this. Someone puts the common ratio as negative 2. And they're thinking, Grace, dividing. Don't think divide. Think multiply. All right, so here we're always going to divide the second by the first to get the common ratio. And then you just multiply to get your pattern. All right, over here to B. Let's do our second by the first to look for our ratio. 6 divided by negative 3, negative 12 divided by 6, 24 divided by negative 12. What are those numbers? Negative 2 for the first one, the second, and the third. So by sitting the same thing on each one, what are we saying? What kind of sequence is this? It's geometric. Okay, so you're going to multiply by negative 2. 24 times negative 2, I can do that in my head, negative 48, times negative 2 again. 96, thanks, Jalon. And times negative 2 again. Negative or positive, Luke? Good. Negative 192. So on A, we have a sequence that goes down. On B, we have a sequence that goes up. Very similar common ratios. All right, now, a little bit of determination, a little bit of judgment here. Take a look at the sequence. Let's see if we can figure out, is it arithmetic or is it geometric? Let's try. What is 8 minus 12? Negative 4. What is 4 minus 8? Negative 4. What is 0 minus 4? It looks like this is what? Arithmetic. Let's just check. What's 8 divided by 12? 2/3, right? What's 4 divided by 8? Half. Is that consistent? No. So it's not. So what are we going to put? What kind of sequence is this? Arithmetic. Arithmetic. If they asked you for the common difference, Tara, you would say the common difference is negative 4. And just remember, the variable for that is a little d, a small letter d. All right, so let's look at B. What's 12 minus 9? 12 minus 9 is 1.333. That's 3. 16 minus 12? It's not a common difference. Let's switch. What's 12 divided by 9? Is that where you got 1.3 repeating?
Yeah.
What's 16 divided by 12? Again? Okay, what's 21.3 repeating divided by 16? Is it again 1.3 repeating? Let's check it. Somebody? Does it work?
Yeah.
Okay. Therefore, what can we say about this sequence? It's geometric. All right? So we're trying to just to be able to determine, is something arithmetic or geometric? Now, if I say prove it, what is your proof? How do you verbiage, how do you put this in words? How do you express why this is geometric? Put it in words for me. Luke, go ahead, nice and loud.
If you multiply 9 by 1.3 repeating, you'll get 12. If you multiply 12 by 1.3 repeating, you'll get 16.
So if we consistently multiply by 1.3, we'll get the next number in the pattern?
Yeah.
Okay, that's one way to explain it. Good. A different way to explain it. Anybody? What is a geometric sequence? It is something that has a common what? Common, what's the word? Common ratio. So can we show that this has a common ratio? Yeah. So we've shown that each term compared to the term that follows it is a common ratio. So you need to be able to put that in words to kind of explain what a geometric sequence is. So far, so good?